Would you believe if I told you that there's an AI or AI systems or something that they're working on which will make AI be able to perform matrix computations at light speed? Would you believe that if I told you that? Well, you should, because I'm telling you right now, where things are, those of us who are getting in early, we're learning this early, we're able to employ these technologies early, have such an advantage. It's unbelievable. You don't have to agree with me, but I'm going to read you this article. Every day we're reading about different advances that are making AI faster, better, smarter, and that's great for us. Let's scroll down here and find out what they're talking about. It says and this is from spectrum.ieee.org. Okay. If you want to check out this, check them out. A microchip that uses light instead of electricity can potentially be faster and more efficient at the complex computations essential to training AI than conventional electronics. In addition, researchers say the new chips may be significantly more secure against hacking. AI typically relies on neural networks in applications such as analyzing medical scans, supporting autonomous vehicles. In these systems, components known as neurons are fed data and cooperate, to solve a problem such as recognizing faces. As neural networks grow in size and power, they are becoming more energy hungry when run on conventional electronics. This has led to some researchers to investigate optical computing as a promising next generation foundation for AI. This photonic approach uses light instead of electricity to perform computations more quickly and with less power than an electric counterpart. Now, this is where it gets absolutely insane, folks. Look how fast everything is getting. Listen to this. It says, quote, it might be around 1,000 to 10,000 times faster, unquote, says Nader Ingeta, a professor of electrical and systems engineering at the University of Pennsylvania. Wow. It says, in the new study, researchers created a silicon wafer that varied in height from 150 to 220 nanometers. My mind is getting blown, but maybe it's because I'm not a pro or anything like that. But I'm learning a lot here. It says the height variations were organized so that the chip could scatter light in specific patterns. When input in the form of light flows into the chip, the output light encodes data from complex tasks. The scientists designed the microchip to perform vector matrix multiplication operations. These calculations, which involve multiplying grids of numbers known as matrices, are key to many computational tasks, including operating neural networks. Whereas conventional electronics perform these calculations line by line. That doesn't even sound great. The new optical device performs the entirety of these computations at once. I'm ready for it. I want to play with it. I want to see what it's all about. I want that in the palm of my hand because I'm going to wield it. I promise you, every bit of AI that I've gotten my hands on, I've used. It has been dramatically a benefit to my life, business in particular. It says this means, quote, one does not need to store the intermediate stage information in a memory, unquote, Ingeta says. Quote, therefore, the results and processes are less vulnerable to hacking. Previously, when it came to designing photonics to perform these kinds of calculations, one challenge that scientists faced arose from how they had to use complex 3D simulations to model the three-dimensional behavior of the light waves inside these chips. This, in turn, made it computationally difficult to scale the devices to larger matrix sizes. All right, we're going to leave off there. Once again, this article is titled, I'm going to give it to you so you can go look it up if you want to. I probably have already put the screenshot in the video, but it's called Faster, More Secure Photonic Chip Boost AI Training. Optical computing can perform matrix computations at the speed of light. I might even use that for the title. I wonder if people actually will believe it, and it's real. Wow. So now that you have that information, everybody, what are you going to do with it? And until next time, take care.